Let's look at the fifth type of mapping, which is called the composite mapping. Let F, this consists of two different mapping. Let F be defined as this and G be defined as what we have on the board. Be two mappings such that the codomain of F is the domain of G. The codomain of F is the domain of G. The mapping which takes an element from X and produces an element in Y via Z is called a composite mapping and is denoted as G of F. What we're trying to say in essence is that these are the elements of X, Y, and Z. So when we have composite mapping, we are going to have something of G of F, which will be equal to G of F, the first one of P. Of P, that is, F takes element from P, from X, this P to O, that will be G of O. Then when G acts on element O, it produces Z. We are going to have Z. We also go to G of F of Q. Q will be G of, when G of F of Q to N, that will be N. Then from N, we have X. Then we have G of F of R will be G of, what is the element of R here? That is M, then M to Y. That's what we are going to get. So this is a typical example of composite mapping. When we have composite mapping, we are talking about, we have two different mappings of functions such that it is arranged as we have it on the board. Okay, as we have it on the board. If you look at this now, you are going to get the result. So when G, F act on P, when F act on P, we have O. Then when G act on O, it produces Z. And we do that in that order. That is what you are going to have. So this is an example of composite mapping. Thank you.